Hey guys, it's me, Graham Barber. I'm just vlogging for the second time. I received a lot of good feedback from vlog number 1 and a lot of good questions that I didn't know how to respond to right away, so I had to do a little bit of research, and this is the product of that research. The main question I was asked was, how am I going to make chemistry meaningful to my students? I knew a lot of ideas of how to engage and make PE interesting and applicable to all my students, but I didn't really have a clear idea of how to do that with chemistry. So I did a bit of research. First, I thought about my own experiences with chemistry. My prof was kind of the standard chemistry prof. Stood up and lectured on the whiteboard with us, furiously writing notes, silent in the class, about chemistry for about 3/4 of the class, and then we would have the chance to work on some of the examples or questions that applied to that lesson that day, and then next day we would move forward, and it was pretty much the exact same thing, except we probably did about 4 or 5 experiments throughout the semester. He was actually a pretty good teacher. I really enjoyed him. It was really interesting. He used real-world examples, and it was easy for me to understand the content. My research found that there's a few problems involved with the command-style lecture and homework traditional classroom. So there are 2 problems that I found in our high schools and internationally. The 2 problems are, when chemistry is taught in this way, it is not practiced in the classroom the way that a chemist in modern society would be working. So it doesn't give a clear example of the way they would use chemistry in society if they moved on with a career. A lot of chemistry nowadays is involved with the research and development, finding new molecules, chemical engineering, inventing new materials. The second problem with the traditional way of teaching chemistry in the classroom is that it does not provide students with the competencies they need for a modern democratic society. What that means is that students don't have the scientific literacy to accurately evaluate a scientific study as a person and form a judgment on it. A complicated process, but it's just looking at those from a whole society, social, economical, and scientific view in order to evaluate these experiments and be able to see if our government or our city is making the right choice. So, those are the 2 problems. Now, how do we fix that in the classroom? Well, luckily, nowadays we have access to technology, which is helping in numerous ways, but one of the biggest ones that I've seen is with flipping the classroom. Flipping the classroom could be using screencasting technology to record your lecture in a condensed 5 to 10 minute form, assigning that as homework, and then when kids come to class, they actually have the opportunity to ask you questions, do the homework in class with their peers, and answer questions. This allows for more one-on-one interactions with the teacher. I hope to condense the actual material and be able to move on to more interesting things, such as experiments, which may actually use more of the problem-solving techniques that are necessary for modern society. I hope to use flipping the classroom to make it still as easy as possible to understand chemistry and interesting using meaningful examples. But I hope that flipping the classroom frees up class time in order for me to do more group work. This is the idea of a concept map. You'll take one idea and then break it down into things that create this idea. This concept map does is it actually provides students with a framework of how to connect all these ideas together. So instead of just general concepts, they have real-world applications to each one of these concepts, and they see how they fit together. This allows for more meaningful learning, and students can piece existing information they have into their idea of chemistry, and vice versa. One limitation is that the actual concept map may get too complex. Another limitation, it may oversimplify some concepts. You don't always have these neat categories of ideas where everything fits in perfectly into one section or another. Later on in chemistry, something I've struggled with is that you have things that fit in between categories and it's more of a continuum. So you can create problems through these concept maps, but it may be good for beginning chemistry. So we have mixtures. Now we look at the two types of mixtures. We have mixtures, and underneath that we have homogeneous and heterogeneous. Homogeneous is something of two like substances. Liquid and another liquid would be a homogeneous mixture. Heterogeneous is something of two unlike substances. So a solid and a gas would be a heterogeneous mixture. For example, air. Air is a homogeneous mixture of many other gases. A solution is a homogeneous mixture composed of only one phase. For example, two liquids. For example, a soft drink. For every solution, there's now a solute and a solvent. So now in the solution you have water and sugar dissolved by the water, and so now we'll show that. Ta-da! Sugar dissolves in water. So now, getting back to the complete concept map. So that's all for today. I hope that helped answer maybe some of your questions about how I am thinking of making chemistry meaningful in my classroom. Have a good day.